A 9-meter prop beam is loaded with 10 kilonewton per meter uniformly distributed load applied at the right 2/3 of the span, and a concentrated load of 25 kilonewtons at the midspan. We are tasked to determine the moment at the fixed support at the left in kilonewton-meter. And to solve this problem, since we have a fixed support, it will induce a reaction that will resist the moment m that we need to solve a vertical force. Let's call this Fy, and horizontal force, let's call this Fx. And we also have a reaction at the roll support at the free end that would eliminate the deflection at the free end. Let's call this reaction Ry. Now to solve this problem, the best way we can do is use the area moment theorem, since the tangential deviation at this point here, let's call this point A, and this one is point B. Since point A is just a fixed support, therefore the tangent line produced at point A is just a horizontal line, and notice that it will coincide point B, which means that using the area moment theorem, the tangential deviation at point B relative to the tangent drawn at A is equal to 0. And the formula for the tangential deviation at point A relative to the line at point B is equal to the moment of the area of the moment diagram between A and B. So we construct here our moment diagram by parts in reference to this point here at A, so that we can neglect the moment induced by these three unknown reactions. So starting at point B, where the reaction Ry will induce a moment, at point A, that is equal to Ry times the moment arm distance equal to 9 meters. So this point here, so this point load will induce a first degree curve with a value of Ry times 9 meters. And for this point load of 25 kilonewton will induce a moment at point A that is equal to 25 times the moment arm distance of 4.5. And for the uniformly distributed load, since this needs to be continuous, we need to draw another uniform load at the bottom to counter the effect of the uniform load at the top. So we still have the same beam with equivalent loading. And this has a value of W equals 10 kilonewton per meter. And for the moment diagram of a uniform load, this will create a parabolic curve. So this is a second degree curve with the value here that is equal to the moment induced by this uniform load. That has a value equal to 10 times the total length of 9 meters times the moment arm distance of 4.5. That is equal to 405. And for the point load, that has a value of 112.5. And for this uniform load at the bottom, this will create a moment at point A that has a value equal to 10 times the total length of 3 meters times the moment arm of 1.5. This is equal to 45. Now we can start formulating our equation. So we have 0 equals the area of the moment diagram between A and B times the centroid going to point B. We have the triangular load above, that is an area equal to 1/2 times the base of 9 meters times the height of Ry times 9. So that's 9 Ry. And its distance from the centroid going from this point towards point B, that is distance equal to 2/3 of 9 meters. And then for the parabolic curve, there's an area equal to 1/3 times a base of 3 meters times a height of 45 multiplied by its moment arm distance equal to 9 meters minus this distance here. That is a value equal to 1/4 of the base. That is 1/4 times 3 meters. We get the distance going from this point here, the centroid of this parabolic curve, to point B. Now for the triangular load, triangular shape on the bottom, that is an area equal to 1/2 times a base of 4.5 meters times a height of negative 112.5 with a moment arm distance that's equal to 9 meters minus this distance here. Then it's 1/3 of the base equal to 4.5. And then plus the area of this parabolic curve, that is an area equal to 1/3 of a base of 9 meters times a height of negative 405 multiplied by moment arm distance equal to, that's 3/4 of 9 meters. That's the distance from the centroid here to point B. Now we can solve for Ry. We have 0 equal to 1/2 of 9 times 9 Ry times 2/3 of 9 plus 1/3 of 3, so that's basically 1, times 45 times 9 minus 3/4 plus 1/2 of 4.5 times negative 112.5 times 9 minus 4.5 over 3 plus 1/3 of 9, that's 3, times negative 405 times 3/4 of 9. Keep solving, we get the reaction Ry equal to 40.0347 kilonewtons. And to solve for the moment at the fixed support, we take summation moment at point A equal to 0, considering counterclockwise to be positive. We have the point load of 25 kilonewtons that will induce a clockwise moment, so it's negative, times its moment arm distance of 4.5 meters, minus the moment induced by the uniform load, 10 kilonewton per meter, times the distance of 6 meters, multiplied by the moment arm distance from point A to the centroid, equal to 6 meters. That's 3 plus 3 equal to 6. Plus the moment induced by Ry times its moment arm distance of 9 meters. It's positive because it would induce a counterclockwise moment. And then we also have the moment induced by the fixed support. So we add this up by m, all equal to 0. And we have Ry that is equal to 40.0347 kilonewtons. We can directly solve for m using our calculator. We have negative 25 times 4.5 minus 10 times 6 times 6 plus 40.0347 times 9 plus the moment that we want to solve, all equal to 0. Keep solving, we get m equal to 112.1877 in kilonewton meters, and this is our final answer.